Welcome back. This is Chapter 6, Gases, and Section 6.4, Temperature and Volume involving Charles's Law. Okay, just like with Boyle's Law, we have a relationship with respect to gases and their properties. In Charles's Law, it states that the Kelvin temperature of a gas is directly related to the volume. Okay, so these have a direct relationship, and that is if pressure and N, or numbers of moles, are constant. So when the temperature of a gas increases, its volume is going to increase, and vice versa. If the temperature decreases, then the volume will also decrease. So if you look here at this example, okay, the temperature is increasing, so it's doubling from 200 K or 200 Kelvin to 400 Kelvin. Okay, as the temperature increases, the volume also increases. So the temperature doubles and the volume of the container also doubles. So we can write Charles's Law as V1 over T1 equals V2 over T2. And you can rearrange this equation to solve for any of the variables. The example down below is rearranging and solving for V2. I also just like to write it out and go ahead and cross multiply. I feel like it's a little bit easier to remember this way and to have kind of a linear equation. Okay, and so what I do is I write out V1 T2 equals V2 T1. Okay, so you can cross multiply here. Okay, and we'll see that more here in a few seconds. Okay, but this is the expression for Boyle's Law. And so the expression we want to solve for T2. So it's asking us on this learning trick to be sure that we know how to rearrange the equation. So we have V1 over T1 equals V2 over T2. We have a direct relationship between volume and temperature. So if we're looking for T2, basically the first thing that we're going to do is cross multiply. So I usually just like to go ahead and cross multiply, just write it out that way so it's linear. Okay, and so we would cross multiply V1 T2 equals V2 T1. So this is what I've already shown you just a few seconds ago. And then now we can solve for T2. And so we would divide through by V1. Okay, and we just rearrange. And so our T2 would be equal to T1 times V2 over V1. Okay, so let's put this into practice with a calculation using Charles's Law. Okay, a balloon has a volume of 785 milliliters at 21 degrees C. If the temperature drops to 0 degrees, what will the new volume of the balloon be if pressure is constant? Okay, our V1, given here, is 785 milliliters. Okay, our T1 is 21 degrees C. Okay, but all of our gas laws have to be in Kelvin. So we're going to add 273 to give us 294 Kelvin. We're looking for the new volume, and our temperature drops. Okay, so this is our T2. And 0 degrees is the same thing as 273 K. Okay, so here we have, be sure to use the Kelvin temperature. Okay, now we're just going to plug in, and we're going to be solving for V2. So if we rearrange our equation, so I like to show, like I said, they're linear after you cross multiply. You get V2 is equal to V1 times T2 over T1. So our V1 is 785 times our T2, which was 273 because the temperature dropped, and our T1 was 294. Okay, and we should get about 729 milliliters. Okay, and so our temperature decreased, and so our law says that the volume should also decrease. Okay, so if you get a higher number than 785, you know that you've done something wrong. You know that the volume had to decrease. And so it did. It went from 785 to 729. Okay, let's do another problem. A sample of oxygen gas has a volume of 420 milliliters at a temperature of 18 degrees C. Okay, so our volume is our V1, and here's our T1. At what temperature in degrees C will the volume of the oxygen be at 640 milliliters? So we're looking for T2, and our V2 is 640. Okay, and so we write out our Charles's law, which gives us V1 T2 equals V2 T1. And we are looking for T2. Okay, and so we're going to divide by V1. Okay, so our V2 is going to be 640. Our T1, okay, is going to be 18 plus 273K. So 18 plus 273 gives us 291. Okay. So our T1 is 291K. Divided by our V1, which is 420. Okay, remember, we have to plug in the values for temperature as Kelvin into the equation, even though it's asking us for Celsius. And so we get 443K. And now we can convert from Kelvin to Celsius. So if we take 443 minus 273, we should get about 170 degrees Celsius. You have to do this at the end. You have to plug Kelvin into the equation, and then you can convert to Celsius. Okay, and just a quick review for Boyle's and Charles's law. We're going to go through and fill in the blanks. Okay, pressure blank when volume decreases. Okay, this is an example of Boyle's law because we have pressure and volume. Okay, and we know that this has an inverse or an indirect relationship. So if the pressure increases when the volume decreases. So if you decrease the volume, you increase the pressure. Okay, when temperature decreases, the volume decreases. Temperature and volume, according to Charles's law, have a direct relationship. Okay, C says pressure blank when the volume changes from 12 to 24. Okay, so it looks like our volume is increasing. Looks like it's doubling. Okay, so if volume is increasing, then the pressure must be decreasing. Or decreases. Volume blank when temperature changes from 15 to 45 degrees. So the temperature is going up, so we have an increase in T. We know that volume and temperature have a direct relationship, so the volume also increases. So here's the answers just to clarify. Pressure increases when volume decreases. Temperature decreases when volume decreases. Pressure decreases when volume increases, so we have an increase in C. And volume increases when temperature increases. So we have a direct relationship between between volume and temperature, and we have an inverse relationship between pressure and volume. This concludes the video for section 6.4.